So this video is quite long and it's all programming. So if you are not interested into it, just skip it. I will put probably as a episode 2.5 because it's not that important for the actual kind of survival type of series. But it is interesting because it shows my logic behind the programming that I do here, and what you are seeing the screen is something that will come into later. So hope you are liking it. So Archean, yeah, that's my color change. Okay. Uh, no, I was thinking and forgotten to put beacons both in the base and the, the rover. Let's call it. We can actually call it the rover. And also, I was thinking about balancing this, and I think the container is the problem that is giving our like uh, like back uh, well, uh, back weight and lifting the front. Also, the battery is a bit to the back, but the battery is quite heavy also. Um, so first things first, the beacons. Uh, so I was thinking, where am I going to put it? And I think I'm going to put it around here because this gives a little bit more weight to the front. Also, I'm going to change some of these blocks for steel. And uh, also, I remember the rover uh, pulling towards the left and having a bit weight on the right. I guess will counterweight this. Takes a while, but beacons are quite cool here because you can program a new HUD, and like you have here. I think this one I copied from the example, I guess. No, it's not this, but it was an example of HUD where I can get a frequency that I am receiving, and it will uh, plot where the receiving frequency is coming from in our HUD. So for example, I will put here rover so we can test it afterwards. Um, we can here beacon. Looks like an antenna, so like I guess older cars had this type of antenna. Uh, Newer cars don't have it. This is what let's put in front of it. Yeah, this is better. Just change this. Let's remove the symmetry. Change this into a slope, so it fits quite well. Let's put the symmetry back in case we want to maintain more fees. Now we need to connect this to the power. So this actually I think I messed up. Yeah. Oops. Um okay, and now you can change the transmit frequency something for I guess rover. So the face device ages would be, and okay, so you have this, but also I guess we need uh else, right? No, okay, it's working. So This is really cool. So you can know where a rover is from anywhere, and this goes into the kilometers. Uh, so it's quite cool. Let's put another one in the base. Actually, let's drive there, since we built this last episode. Okay, this artifacting is quite annoying, but it's from the ray tracing technique, I guess. So let's put another beacon here. And since it's low voltage and it's quite, let's say, essential, let's put it into this battery here from this junction. And let's put it upside down, why not? Actually, let's be a little bit realistic at least. Put it inside. Then base. Transmit frequency space. Okay, cool. Now we can adjust here to frequency space. And turn it on. Successful. And we know where our base is. It's very cool. I don't think I ever saw anything like this in any other game. I guess actually Stationers has something close to it, but I never ended up using that function. But as I promised, let's change a bit this rover. So first of all, let's move the symmetry again, because I said we were going to put some steel blocks here, or I think I said that this. Let's make steel blocks to serve as counterweight for the battery and the container. Okay. Symmetry. Okay. So this. Scope. Okay. You can put more stuff in steel, like this. Right here, and maybe this one is a good thing to put. Yeah, that's the front part of the rover now. So we have some weight forward. Let's see if it helped. Just a little bit. No, it didn't. At all. So yeah, maybe we will need like maybe another battery somewhere around here. Maybe something below the dashboard or that. Maybe remove the container. Just leave it as something like decorational. And yeah. But as I promised, let's program our scanner. So this will take a while, so buckle up, because it has way more logic and also drawing on the screen than just driving. So let's start by making a new file. Or and let's start by creating a with variable. That's the ore that we are going to scan. Let's start with like iron. And let's also include scanning here. So this is going to take a while, so really I'm preparing myself for this. First of all, let's do a function like draw screen, and here we're going to actually we need the screen be the screen in the dashboard. So I've forgotten how we do it, but I guess there is a way to do it here. Color. Okay, I'll look into the wiki. Okay, so my game crashed, but this game has quite frequent autosaves. So I saw it's quite easy. Actually. It's just a screen, and then it is like its main dashboard, and the parts number. So 0 in this case, I believe. So channel 0 is a screen of 100 centimeters, 200 by 200 pixels. So right now we can already do quite a bit with it. For example, I think let's get that up now. I'm sure that what I'm looking for is here. So for example, blank, black, but since we aren't blinking the computer screen, it's a dashboard screen. We have to do a screen with blink, I guess. We put some color here. So let's you need to put draw. Okay, so here's what I was talking about, making it transparent. So the screen is transparent because we put a 0 as the color, but it could do, for example, black. It will turn black or blue. Yes. Or no. Okay. Open again. I think. Yeah, there is red. Right. But I guess it's without yet. The cipher. Okay, so we can draw the screen. I like putting it at 0. But we can also color 0, which is black, but put it slightly transparent instead of completely transparent. So I guess this has some, like, it's a bit prettier than just completely transparent. In fact, I'm going to a little bit more opacity into it. Not too much. Let's leave that maybe. So we have this screen now, and we can draw many things here. And oh, it had here, so you can, for example, draw a circle. But first, let's do a I guess the screen is a constant. I I can do it. Can't do it. Um, let's make a screen with um, actually there is a way to keep stored the variables our screen width number. The same with the height. Just so we don't need to get this variable every time, since it's nothing, not something that will be changed a lot. So here in it, we can make a function here. Uh, like start up, and this will take the screen width and height and store it. So it's screen, but I believe it's screen W. Here it goes like this, but let's try. Actually, I think it's best width. Let's, instead of only draw a screen, let's do it. Sorry. Let's scan. That's the name, right? Yeah. And basically, the naming here, I put uppercase letters where I want this to be called by another program. So the draw screen will be internal to this program, but startup won't. And so we can like differentiate them. So we can put stop draw screen here, but since we are testing it, let's leave it. So let's print the screen width to compare if it makes sense. I think it was 200 pixels. Yep, 200 by 200. Let's do the same with the height. Okay, now we have these values to play with a little bit. Let's also make a background color to be 0. Yeah, this works. So, yep. So now if we use the background color more times, then we can just replace here and not here. So let's also add a foreground color, or let's just call drop it. And let's make it green, why not? And here, let's draw a circle like it does right here. So it has it draws a circle of half the screen width by half the screen height, and the center is it's a circle, so it only has one radius, and at the center of the screen. Let's actually copy and paste this just for its sake, not here. Cross it. And this and drop. So now we have a little circle here, but the radius is I would say a bad in a bad way. We are hard coding the radius, and I would like the radius to be uh, comparable with the screen size. So here we can do another storage bar and make it like the raw radius. And then raw radius minimum value between the screen width. Right. I believe that's the way it works. Let's draw. Yeah, sorry, but of course over 2 because it's the radius, not the diameter. Let's actually put times. I prefer the way it looks instead of dividing by 2. But now the circle takes the entire screen, so it doesn't let us have more interface, just the corners. Basically, this circle will become our like a sonar circle where we can search for minerals inside the circle, and the circle in the screen will be a radius that the ore scanner is searching for. So for example, this when we are seated, right in front would be those mountains, to the side would be those mountains, backwards would be the sea, and to the right would be the sea. But again, this doesn't leave much room to play with an actual interface, just the circle that will. We want it to be big, no, but this is too big. So let's create a margin variable, actually a constant margin, and let's make it like 10 pixels. So now the radius is this minus margin times 2, because we want the margin, actually just the margin, because we want the margin in each side, in top bottom. So now we have 10 more pixels. Still a little bit too little for my taste, so let's maybe 20 pixels. Yeah, I think this is, yeah, this looks cool. Yeah. We could do the margin be related to the screen width or height, like the margin is 10% of the radius or something like that. But I think doesn't need to. So we have the scan startup here, draw screen, and we are drawing the circle at the center of the screen, the draw radius and the draw color. I like the green, and let's actually I don't like how the circle is like shadow, making a shadow in the lower surface. So let's just do it like totally opaque, at least for now. Actually, we can go back and draw the circle again, but now we put an inside color, like so now the inside circle has a color. It's still like shadows, the lower surface that we are seeing, but at least like the inner part is very clear that what isn't black will be our ores, right? So we drew the circle. Let's just to remember uh, the main circle. Uh, so right now it's just a circle, and we can maybe do some buttons right now. So let's make an array, and let's change this just for here to storage or and it will be a text. So we only like we only basically the storage, what it does is when we reboot our computer, the the variable is still there. We can it still has the same value. So for the first time, for example, we can put a scanning or equals aluminum, for example, which I believe it's the first in alphabetical order. That's why I'm putting here. And I rebooted by saving the file. We can also boot manually here. But then if I remove this, reboot again, and now just print what's the scanning or it should be aluminum, even though we aren't inputting it again. So yeah, the screen width and range and height and that kind of stuff doesn't need to be stored, but I guess it's a good way to do it. So now we have a scanning OR, and we need to display it. So let's screen. Not, I believe it's right. Scanning OR, and it's at position, let's say 0, with the draw color. No, it's okay. Right command. Oh, right. Yeah. What I'm writing is. So now we are writing aluminum here, which is our scanning R. We can do something better, like writing at maybe half the margin. And now it has some, it isn't like in the very corner. You can also do that, I believe it's text size. Let's see. Yep, text size, and like do it a little bigger so we don't need to zoom in to know which R we are looking for. I don't believe I can do floating points. Yeah, it rounded up, so 2 is fine. In the future, I also want to input other Rs, so I saw in the workshop a way better program than I'm going to do here that can scan multiple ores at the same time. Like, I believe it's 3 ores at the same time, and I want to do it, but that's in the very future. So, we wrote this, and I'm going to put the text size back to 1 so I don't forget and put every text in size 2. But also, let's comment here. It's the current or UI. Let's also draw a rectangle here. So these coordinates, I believe it's the bottom left, sorry, the top right, top left coordinates of our text. So exactly here. So if we draw a rectangle with this starting here and going, let's put to the margin just to show. So it will start in this corner and probably like around here. So quite bad, but at least it will be a background for our text. And let's put the color like with the drop color as a I guess rectangle. I think it's rect. Oh, oh, it's draw rect. Okay, so terrible, but also colors are switched, and we can do a better sizing, right? First of all, we can remove 1 pixel just so it starts before. Actually, I'm not going to do this, but I will save the code for later. What I'm going to do to like, oops, stop the vehicle. What I'm going to do to like make this text pop up a little bit is just drawing it first a bit lower and to the left. So I think it's -1 + 1, and instead of the draw color, it will be black. So now it has a little shadow thing, and I think it's better. I think it 2 pixels to the left and to the bottom, maybe too much. Oh, I think this looks cool. The shadow doesn't, but I think this is maybe 1 to the left, two down, not maybe. Yeah. Anyway, it's just detail. I like this kind of stuff. Just for comparison, let's see how it looked before. Yeah, I think it's nice, very little detail. So now we know which ore we are looking for, and let's actually, oops, sorry. Let's actually draw a rectangle around this, but an imaginary rectangle, so that when we click here, it changes the ore, right? For this, I believe I need to do some kind of list, which was what I was doing here. I don't know if I can. Yeah, I can declare it an array here. So storage array, and it will be the available ones. So this will be an array that has all the ores basically, and we can start up this by available ores paint. I guess, for example, and we can print ores. Actually, not a very good idea to store it and be a painting every time. Maybe just doing equals to. And the array in this programming language is quite weird, I would say. I have to do like dots, so aluminum. Okay, so I figured it out. I used this function, so let's separate this since it's now not ours, not this screen. So we can use this function to put in a text like this one, and then say what the separator between items are, and also we have to print each item. I think we can print the array, yeah, directly. So we can expand this available ores array afterwards, but I guess for now this will do. This will do. And also I will change the scanning ore for a number, which will be the index in the array where we take the ore to scan. So, or actually I can also change, make another variable, like scanning. It's this. So, okay. Now we have the available ores, which I'm going to take out of storage since every time we start up, we overwrite it. It's not necessary, but I guess it's better than storing it. The screen could change, but the ores won't, unless like, yeah, the ores just won't change. So now we have the available ores, and we can, instead of putting scanning ore here, really, let's make a function. Change scan ore by value. So basically, this value will be a number, and if we change by 1, we go forward in the array, but if we change by -1, we go backwards. And we have to make sure that we don't go into the -1 index, or an index that's greater than the size of the array, right? So first of all, scanning index plus index plus value, and then we have to modulate this by the size of the array, right? So we can use the mod operator, modulus modulus operator, using the available parts. That's nice. So if, for example, scanning index is 3, and actually we have to put a initial value for the scanning index. just so it doesn't recount when we do this addition. So if it's 3, sorry, 2, which would be gold here, we increase in value, this sum will be 3, and then we mod by the size of the array, which is 3. So 3 mod 3, 3 mod 3 equals 0. So it goes back to the first index. I can't remember how the mod function here deals with a negative value, but I guess we can check it, right? So let's also, when we change the scanning index, we also have to check the scanning or to be the available ors scanning. So, for example, if we change to aluminum, then the index will be 2, and the score scanning OR will be the available ORs in position, sorry, 1, not 2. 2 would be gold. So anyway, can do this and also print the scanning index and print the scanning OR. But we have also to call the function. So what's the name? Scan R. It's changed by 1. So now it's 1 and it's aluminum. Let's reboot, since both of these variables are storage for variables. By rebooting, we only like run this code again, but with the aluminum. So let's reboot. Now it's gold. Let's reboot. Now it's silver, and it went around the array back to the index 0. So let's try -1, and it doesn't work, right? So if the scanning index is less than 0, we can go back into the array size. We have to change the scanning index to be the available size. So if we did like -1, so for example, the scanning index is -1, so we would go from silver to gold in this example, and so the new index should be 2, and the size of this array is 3, so it's 3 -1 to be 2. But maybe I want to change the value by more than 1, so this wouldn't work. So instead of doing -1, I will do minus scanning index. So in that way, for example, if we go from 0 to -2, that would be -1 is gold, -2 is aluminum. So 0, -2, so the new scanning index is -2, and we go from available ors, since it's less than 0, we get the size -2, which would be, in this case, 3 -1, which goes to aluminum. So of course it doesn't work. Why doesn't it work? Oh, okay, the scanning index is 4. Okay, because the scanning index is already less than 0, so by subtracting it, we are actually summing a positive value. Now it works, but another problem is that, for example, if I put a value that's bigger than the length, like then, it works. Okay. Okay, so 0. Let's reboot, and it should go to 2. Okay, it works. I guess the mod operation here is doing some work into, like, if I put -10 here, then it's still between -0, I guess, or n minus r size -1, right? So in this case, in between 0 and -2. A bit complicated, I guess, but it's working. That's what counts. So now we have a new scanning R, and let's actually call this before the draw screen, because I was seeing that the printing value wasn't matching this screen value. Well, actually, we aren't going to use it. We are going to make some buttons to change it. So this was the current R. And let's draw the so but let's draw triangle. Let's rename, and we need to give 3 points. So I want to draw 2 triangles, basically, one right below the aluminum, right below which R we have selected and pointing up, and another below that pointing down, so it would be like an up and down arrow. So I think that's a good and like intuitive way to draw it. So to get the size of this text, we can actually use this this function, I guess, or value, character height, and we need to put it before changing the text size back to 1. So let's get text sizes, which will be a variable or text height, just h is fine, which will be screen h, and this will give us how many pixels the letter has, right? And we can also do text width, but I don't think it's needed. Actually, let's do it. And although sometimes, like with tungsten, we have only one character, let's always assume we have 2 of them, and then we can like center the text instead of centering the arrows, right? So this will have to be like here. Or UI. Okay. And we can already center it, but let's draw the triangle first, which is I guess cooler. So start X will be at the same place where the text starts, right? Because I want the triangle to be um, as uh, well uh, as long as the text, right, in this direction. So you can start here, just below the A, and stop here, just after the L in this case. So start X, and int X to be start X plus R width, right? And for the Y, we can do something closer. So start Y is the same. It's the start of the text, but the text starts from the top. So we have also to add the our text height. And I don't want it to be just below the text. I want to be like maybe 3 pixels below it. And then Y, we can improvise somewhat with it, but I want the button to have the same height as the text, so I basically add one more text age here. So let's start with the points. The way you draw triangles in Xenon code, which is what Archean uses, is you put the x point, y point, x point, y point, x point, y point. So you have 3 points and xy coordinates of each one instead of like x1, x2, x3, y1, y2, y3. At least I believe it. That's it. So let's start with start x, right? And start. Actually, I don't want the start y because that would be the top y. So let's use the end y, which will be the bottom coordinate. Then for the next x, it will be half of start x plus end x. So the average between them, and this one will be at start y, and then end x and y. And color, let's put black. So our text W. Okay, it doesn't have the. Okay, now we have a very sad triangle. Why is it like that? Let's put black. Maybe the draw color and black like this. But I guess, yeah, from outside doesn't look that bad. Maybe we can make a smaller triangle. That looks a bit better, but also the text doesn't line up here. I guess because L is such a thin letter. Yeah, maybe we need to correct this later. And I guess for now this button is cool. And let's make the other one. But also these variables are getting like, since we have to put so many variables to a function call, I don't know if we can do this, we can't. So maybe shortening the names would be a good idea. Let's put then x1, x2, y1, y2. So it's 1, 2, it's 2, y1, it's 2, y2, and that's much better already. Start axis on fine. It's next one now. Okay. So let's now draw the other rectangle, but now the things change a bit because the y1, which will be the, let's say, the pointy bit, it will actually be y2, which was where our triangle ended. Let's say plus 1 pixel. And now y2, which y2 will be that, because it's the flat part of our triangle y2, and the pointy bit, which is y1, will be now 2 plus half of the or text height, right? Just like we did before. So now we have this, maybe, yeah, a few more pixels below. 2. This looks better already. We can fiddle with it a bit more. 0.7 instead of 0.5. Yeah, that's already better. But then we have this alias thing, aliasing. Yeah, maybe that's fine. 6. Yeah, I guess 1.7 was fine. Let's try 0.8. Yeah, this is much better. Okay, so drawing was the easy part, let's say. Now we have to do so that if we click on it, then something will happen, right? So in that case, we probably want the upper arrow goes adds 1 to the OR index, and the down arrow goes down in the OR index. So you can see that there is this function with button, but I remember being quite tricky to use it. But let's try. Okay. So first of all, instead of I remember what was the problem. It was refreshing the screen, because we are drawing the screen every time, but we actually want a kind of rule for when we draw the screen. For example, when we click the button, we want to redraw the screen because now the OR is different, so we need to refresh it every time you click the button. But let's first do the button and you see what I'm talking about. So not button. Okay. Then we are going to change skin by 1. And then do the same thing here, but negative. Right. So if I click here, nothing happens, as you can see. And let's see if or every time it changes. So I guess it's a good way to verify it. So instead of drawing screen only when we initialize, let's put into the tick function actually, just for testing. So now we are drawing this same screen every tick. So when I click, it works. But drawing the same screen every tick is kind of bad. Like you are doing so much more stuff than you should. Um, because like for example, um, if I draw a an or vein here, and every tick the screen is being redrawn, then that or vein will be uh, erased, right? So instead of draw screen, let's call this like um, instead of uh, maybe like blue screen. Uh, so so that makes more sense because when we we draw it, we actually call for a blink function. Uh, and while we don't want to clean the screen, we can draw on it instead of like clean it and draw it again. So actually this text size can come here. No, I think it's quite organized. Maybe I put that this is upper bar button. This is the lower bar button. Yeah, so quite well organized, I would say. And instead of doing the clean screen every tick on the main file, let's put it here with an interval. And I forgot how timer uh, frequency of 10, and let's make a new variable for to to identify when we need to clean the screen. So for example, can get here where date screen equals 1. So when we start the program, the screen will be dirty. As you can see here, it's just all black. And if dirty screen, then we can clean the screen. But now, as you can see, when I click this, actually it is changing. Why is it changing? Oh, also, when we clean the screen, obviously we need to set the dirty screen to 0. But now, if I click it, you can see that the screen doesn't change. So when we change the scan or, it's something that will put dirt on the screen, let's say, like that, because uh, the screen is not updated. So when we change the scan or, it's dirt screen will become black. So now, when we change it, it should have worked, I guess. Check. I already know what's happening. So basically, when the see that we are checking if the screen button. Like this makes little sense for me, but basically um, we are checking if the button is clicked while it is being drawn. So uh, so if we aren't drawing the screen every time, then the button isn't being drawn every time. So when we click the button, it isn't being drawn, so it isn't being clicked. So um, we may be want to put this uh, to refresh the screen when we click it. So this documentation here has the click function, but I don't think I can do screen not click. Let's check. And clean screen. Yeah, I can't do it, but um, let's get um, a way to get the input for a click. I guess it will be in the dashboard documentation. Right. Components. Archean dashboard. Okay, we can use the click, but it's click, but and is it a yeah, yeah, it is. So and this gives us the X point that was clicked and the Y point that's clicked. So maybe we can redraw the screen, sorry, the buttons only when the screen's clicked. But I guess it doesn't hurt to just do a screen. Now it works again, but every time you click anywhere on the screen, it will uh, refresh um, the entire screen. So maybe what we can do is draw the buttons and the UI before the or circle. So for example, we get this and this, the blank actually yeah, we can actually do if there is screen. Then we blank it and we redraw the circle. Otherwise, we skip this part and don't like refresh this part of the screen or anything else. Just basically do the buttons. But also, if the screen isn't dirty, then we probably don't want to write this again. So let's put another dirty screen. Yeah, and now it should work because not. Okay, I see, I see, I see. Ah, I see. Okay, so basically, what was happening was we call the clean screen here, and it if it's dirty, it will uh, clean this part and redraw the circle, and it will also draw the buttons, right? But after drawing the buttons, it will be then dirty again because this function uh, uh, makes the screen dirty because we clicked the button and there is something to update. So uh, now it will be dirty, but the function continues and uh, gets to this if dirty screen and uh, basically uh, overrides this that it is dirty before it can have time to redraw to come back again to the beginning. So let's update the dirty screen before the buttons. So should be any buttons or uh, or uh, requests to withdraw this. So now it should work. No. Okay, it's working sometimes, I guess. I guess just the frequencies too. Yeah. Yeah, sometimes it doesn't work. I guess frequency maybe. Yeah, now it works every time. So yeah, finally we can just select which art we want. But anyway, this was just a small error that only will be happening once. Now, now it's a cooler part of actually drawing where the ores are on the screen. So let's start. First of all, let's make a function to actually scan the ores. So let's do it here. It's like a good place to be. Ores. Scan or tick, let's call it, because you have to continuously scan for ores. And what do we want to do? It's take quite a bit of the show. Uh, uh, I need to look a bit on the documentation for this, so I'll just okay quick to to see to remember how exactly the R scanner works and the pivot works and how I want to do this. So during the editing part, I just realized that I never talked about what my plan is for the drawing and the sensing part of the or sensing and the or scanning. So I'm just going to explain this because somehow in 2 hours of video I couldn't explain it. So basically we have the OR scanner here, and it scans on a line, right? Actually, it doesn't scan on a line. We say what distance from it we want to scan, and it scans this distance only. So, for example, we want to uh, scan in 10 meters, 20 meters, and so on. And uh, basically, we have these dots of data. So to draw it, if we had our screen here, basically the green circle, what we would have is we are right in the middle, the R scanner is pointing forward, and we have some dots of data along this line that the sensor is scanning, right? And this doesn't do much good. Basically, we have one direction of data. So that's where the pivot comes into. Basically, we turn this sensor around. So the next data line we get is at some angle, and now we get other dots, basically. But this doesn't solve all problems because now we have to draw this on the screen, and it isn't a very good idea. At least I don't think so, to just scan for every pixel on the screen, because you have lots of aliasing problems. Basically, our screen is made of pixels, squares, and then you have some line that kind of goes at some squares, and you have to do a lot of mathematics just to know where to scan, and even then it's terrible. So what I am going to do is basically we have oops, you have our screen here, and we have some angles, right, where we take data. And then what I am going to do in the video is basically draw a polygon that goes ha has one corner in each data point. This isn't exactly great because, like, for example, like what color do I color this? Um, Basically, the color is how much ore is in it. Is it this percentage of ore? Is this one? Is this one? Is this one? Is an average? Well, what like it's kind of terrible. So I guess outside of recording, what I did was basically we have again these lines with the dots here. This doesn't change because that's how our scanning works. And what I did was change the parameters for the polygon so the data points are in the middle, so that that problem doesn't show anymore. And I guess this is much better. Also, another thing that will come into is basically we need to know what angle this is at. So what is this angle here? And we could use the I think it's step motor, uh, the mode of the pivot, which allows us to just say point at this angle. For example, this theta 1 here, and then point at theta 2, and then we theta 2, sorry, and then we have what are both of these angles, and what's the difference and everything. But that's not how I did it. I just my preference was just to set a irregular speed, right? And this angular speed is just constant, and we don't change it from the moment we start the computer. So what we need to do is just ask for the scanner to tell us what these angles are when we are scanning, and hold on to the previous angle so we can know where to draw the things, right? So I guess that's it. I hope you are liking it, even though it's 2 hours of video. Okay, so I have the wiki opened here in the screen, and it's quite simple. I can't uh, can't believe I forgot how it works. So first of all, we need to define how far we want to see the R's. So I guess here is just as good as in place to put these variables. So be another storage variable and scanning radius. And yeah, um, let's also make a very similar thing that we did with the R's here. But on this side, I think it's good because while we are driving, we can see, sorry, how far we are scanning and which R it is. So this screen don't need it anymore. Okay, if you want. So let's do something similar over here. So first of all, let's learn this for now, and let's just copy this function, but instead of changing the scan R, it will be changing the scan width, and that will be a value. But this value will be like probably +1 -1 or something like that. I want to just know if it's positive or negative, so I can go into predetermined distance, right? So for example, let's say the value greater than 0. Sorry, if the scanning radius, it will be in meters. This. If the scanning radius is greater than, let's say, 10 kilometers, actually, yeah, it's in kilometers, greater than 10 kilometers, then it wants to change, for example, uh, the, the, the distance by values of 5 kilometers up, but 1 kilometer down, so you can have kind of a variable range. So if it's greater than 10 kilometers and the value is greater than 0, so then the scanning radius will be updated by 5 kilometers. Else it will be updated by else actually 1,000 times let's put so nah, it's a very bad way to do it. Maybe value Archean, that's too much Python. And if basically the value isn't greater than 10 kilometers, or the value is negative, we want to change it by 1 kilometer. Okay. And the screen will be dirty because we are going to put this on the screen. So it will be more buttons. So we were writing on the top left. Let's write the top right now. So current UI. And it will basically be the same thing but negative, right? So we have we will start from the screen width, but minus the length of our text. And to get the length of our text, I guess we can use a function. I believe there is a function that directly gives us the size of the text we want to write. Like you put a string and a like to be like this screen.text size, and you put a string here and it says how long that text will be on the screen. So let me check this. Yeah, I didn't find it, but we can do change the text align. And it's and afterwards we can change it back to top left. So it doesn't. We have to change it back. The text size doesn't matter that much because we are using the same text size for both texts, but we have to change the alignment back because this one is aligned left and this one will be aligned right. So the math is a bit easier because then we can put the x value is just the screen width minus the margin plus 2 in this case, because it will go over there instead of go to the right instead of the left, and the same for the bottom right. Instead of scanning, or let's make a string for this. So then put this into text. So here I have it. So first of all, let's do the scan. Or actually, how is it? Scanning radius. If it's greater than or equal to 1 kilometer, then we are going to write it as a kilometer, and if it's lesser, then we write it as meters. So then radius str equals to dash. So round is constant, rounds to the 0 decimals. and the text will be just this lines. And this here will be the same but in meters, so, and without dividing by 1,000. Where did I? It's line 69. Okay. Guess we have to do it like this. And it's type to be text or equals. Okay, just equal to nothing. No problem. Now in 73. Scanning radius 0. Okay, it's because the scanning radius doesn't have a value right now. Well, let's just put it. The startup here has like 500 meters just to start. Now another problem. It's just set 0. What? It's 500. It's 500. Okay. And take it away since it's a storage variable. Why is it 0? Oh, now it's in 74. Okay, because maybe it's the wrong function that's the problem. Okay, it was, but I still don't know why it's returning to 0 every time since it's a storage variable. Let's try it again, maybe without a error. It works. Yep, it works. Works fine. And this reduce string. Let's print it here. Here. And it isn't writing. I think it's because it's outside of the screen. Oh, the screen isn't dirty, is it? No, it starts dirty. And we can check. Okay, so it is doing it. Let's maybe print the weight of the string. 100 meters, which is fine. Why are you not writing it? Doing that right, just like up here, like register. Okay, you win. Let's align to top left and calculate how much we want this. So minus or next width times radius screen dot set. Okay, it's starting to work. But why is it so far to the right? Okay. Not going to use it then. That's it. So where are we starting this this text? The height is fine, but screen width. Okay, so we are starting here. In fact, we need to go back a little bit. So we are going back 2 pixels plus half the margin, which is the same margin that we have on the other side, this side. And okay, this one begin. Oops, something that I don't want to. So at the actual draw color doesn't have this much stroke. So we are going back some margin and then the or text width times the rigid string size. That's, I don't know how I did that. Let's print the size of the string. Oh, okay. So that's a problem, I guess. Maybe it's length. Okay, so let me see in the documentation how you get the length of a text. Oh, it's size. This, okay. So okay. No, I guess that's better. But why is it so much to the left now? And they are like relatively okay. The shadow and the actual text. So I just need to move them to the right, but why is it the screen width? Oh, okay. The Artex W is actually 2 times the because it's already for the or name, nor the not the not the each character. So either we do half of it, but I think it's better to just do this one. Yeah, that's much better. But let's take out this space because it doesn't have too much space. And let's put a little bit less margin, maybe. Yeah, I think less margin. 5. Yeah, that's much better. Now we have to do the buttons again, but the buttons are just copy and paste and change which function it calls. Let's do it here, and now no, let's do it afterwards. So here y1 and y2 is for the lower button, so just have to change x. So x1 will be let's put this in margin, but now it's negative, right? And we need to put it on the right side of the screen, so W, sorry, and oops. Actually, is this x1 or x2? Yeah, that's x1. That's right. And then x2 will be this same thing, but no, negative, because we are going right to left. And we draw the button again, and this will be the lower rate. Instead of changing the scan or we change rates. And now we have to undo this this transformation for the y variable to do the upper one. So the y2 now it's y2 minus 2. The y1 actually we can just copy here. So y1 is this again, and y2 is this again. So like this, perfect. And change scan radius, but this one's the positive one. So perfect. And when changing the scan radius, we already dirty the screen. So if I click it, an error, okay. 70. 70? Okay, it's probably this round function that wasn't working before, so let's check here. How do I write it? Oh, okay, I can actually write like this instead of rounding it. Okay, 1,500 kilometers. I don't think that's right. Okay, delete it. So 2 kilometers. That's also not right. Why is it? Is it not right? Let's print the not the radius string, but the scan radius, and see if it makes sense. No, it doesn't. So that's because okay, it started with 500 meters, and we added 1,000 meters. So of course it's 1.5 kilometers. But instead of it, let's check if the scanning radius is greater than 10,000. Actually, yeah, done 1,000. So basically the same thing from over here. If the radius is above 1 kilometer or equal to, I should put it, and the value is increasing, then we can go up by 1 kilometer at a time. Otherwise, we know this value is also lower. It's lower than 1 kilometer, so we can go just 100 meters at a time, maybe, and we can also limit it to the scanning radius is now lesser than 200 meters, let's say. Then we just keep it at 200 meters. But instead of doing like this, we can just do it like scanning radius equals maximum between the scanning radius 200 meters. We can also limit upper, make an upper limit so it doesn't get too crazy. Maybe at 100 kilometers. I think that's fine for now. If we need more, then we can add it later. So nice. Now when I put it down, fine. 100 meters at a time, and I get to a kilometer, change 1 kilometer at a time, and we can check that the value is the same with the printing. So now going down, okay, so going down it's going 100 meters at a time. And okay. If the scanning radius is greater than 1000, actually, if it's greater than 2000, we want to go by 1 so right, because then, for example, right now it's 7 kilometers. I'll go down to 6, 4, 3, 2, 1, and now it's 900, but still going up. It's okay. Yeah, I think this is a good way to do it. So, so this is actually a we can simplify this to this. Actually, let's put 4. Can get rid of this. Yeah, perfect. Let's take out the sprint. No. Okay, now we can finally start with drawing the actual ores on the screen. So, scan Arctic. Let's do it. So, to scan the ores, we need to input into the ore scanner a number. So, actually, let's put numbers. My God, what is it? Okay. And to the channel can be basically anything. So let's say 0, so the first channel, and we need to specify a distance. So let's say in channel 0 you want to see 10 meters forward, and let's say in channel 1 you want to see 20 meters forward. Then that's it. And then we can get input text from the ore scanner, and then the channel 0 will be the results that what the ore scanned, what the ore found, and in 1 it will be for the same for 20 meters instead of 10. So we can do better than this. So let's say we want to repeat 100 times, then we can get our current radius that we are current distance, sorry, that we are scanning, and this will be the scanning radius divided by 100 times I, right? Except I starts at 0, I believe, so it will be I plus 1. So that way, for example, if our scanning radius is 1 kilometer, then we want to do 100 scans between 0 meters and 1 kilometer, so it will be 10 and 10 meters. So it's actually very, very fine. Yeah, we can maybe do 20 and divide by 20 here. That's 20. Now this is the current distance, so we can do that this output into a certain channel, but instead of outputting to channel 0, it's going to be channel I, and we are looking at right this, and then we can get the results from this scan. Channel I, and this will be result or sort current scan, let's say, and we can print it for now, just for just to look at it. Oops. Sorry. So now every time we call scan RT, it will scan 20 times in the R scanner radius and print us the results. So let's do it maybe with some frequency here. Let's say 10 Hertz. And now it shows us the results, but in fact, let's do it so it doesn't show us so many times. So this is the format it gives us, and we can access each OR by using something like, for example, we are scanning for one specific OR, so we can do current scan dot and our scanning OR. And that will be like the contents, right? So let's print contents. There's nothing because we didn't find any aluminum. But if we put maybe like iron here in our OR list and change this to iron, now in the next scan we may see something, right? Yep. So there is actually a quite rich vein of iron. We can see that there's 77% iron somewhere in 1 kilometer forward as our scanner is pointing forward. So let me get out of this chart. The sun is already setting from how long it takes for us to program. Us, by us I mean me. But our scanner is pointing forward, so somewhere in 1 kilometer distance here, there is a very rich iron thing. But instead of printing it, we want to draw it. So let's do this logic. Also, we hard-coded these 20 samples, but I think we can do a constant or any number equals to 20 in this case. I think we can do this. Oops, not far. Straight. Okay, it works. Now we can control it more easily. So if we want finer sampling that we just change that and reboot the computer. For now, let's go somewhere it's going to be like this. We can put some flashlights and headlights afterwards, even though there isn't a way to do it by code yet. So so you have the ores here. We are getting the scanning. Now for the draw. So for the drawing, every scan or tick, we are going to read from the pivot what angle it is in. So let's get a variable here. Let's get rounded screen. I guess margin can be together with this. Pages. Okay. So it doesn't need to be a storage variable. Just a variable for pivot angle. Get number. And also the pivot previous angle. So what we are going to do is get the angle for the pivot and the previous angle and basically draw that that scanning result in this little change in angle. So for that, let's get our scan or tick and put so the previous angle now will be whatever it was before, and the angle will be the input. I think it's scanner pivot. Let's see, doesn't complain. Print maybe the angle is right, which is 0 because it isn't moving. So so we also need to input a speed for the pivot to be rotated. Let's do it maybe the startup, makes sense for now at least. So output, sorry, it's pivot, and I think so. The wiki doesn't have which channel it is. Let's see, maybe here it has. So it's in servo mode, but I don't want in servo mode, although it would be useful. So let's try. Sorry, maybe 0. No, it's moving quite fast. Maybe 0. Yeah, better. So now, each time our scan will be done in a different angle, and this angle is measured between 0 and 1, which is quite weird. So yeah, there's also its continuity, obviously, when we go from 1 to 0. which we'll have to note when we are drawing. So now our pivot is running. Let's just check the battery. It's been fine. And basically we are going to draw it in an arc. So first of all, so first of all, let's get what's the radius we are drawing on the screen, which will be basically the front. Let's actually make it any variable. Let's put it as normalize it. Right. Which will be just the n plus 1 sorry, I plus 1 divided by the number of samples, and then we can just multiply this by the normalized front distance, and then we can have a raw distance, which is the normalized distance times draw radius. Actually, let's put current draw radius. So we are going to basically drawing in polar coordinates, but obviously our screen is in Cartesian coordinates. But first, let's have so to do this conversion, let's have x1, which will start at the center of the circle. So draw maybe screen w times a half plus whatever plus the cosine of this angle, right? And there will be 4 points we are going to draw. Maybe we could do more, but I think 4 is fine for now. So so it won't be exactly a rectangle, it will be a like an arced rectangle. I don't know how to call it, but so the first x, if we can imagine that if the angle is 0, let's start with the angle 0 being this one. We can change the phase afterwards, but if this is 0, then x is the radius times the cosine of the angle. So if the angle is 0, then x is the radius. But since it's oops. Okay, we will have 2 x's basically, because we will have 2 angles. So the starting angle will be the previous angle. So this and x2 would be the current angle, right? The same for y, but using sine. Okay, so now we have 4 coordinates, two coordinates in the Cartesian space, and we can draw it. So let's draw volume. I believe it's like this. You can look at here. Draw volume. Then first is the draw color. Is it drawing color? Draw color. Okay. Now the 4 points. So first point is x1, y1, then x2, y2, y2. Sorry, it's not x2, y2. It's one of them updates and the other one doesn't. Then it's x2, y2, and then finally it's x1, y2. So actually I think it's better to make sure. I mean, doesn't use. Yeah, it's just drawing a polygon, but I don't think. I think this color is the like filling color, not the outside color of the polygon. Well, let's draw. Let's see how it goes. Why is it like this? Oh, right. I'm just summing the cosine of the angle, but we actually need to multiply this by the draw radius. Let's copy this. Okay, so something went terribly wrong, but I think this is changeable with just reducing the interval, because basically the delta angle was too high. So we can see it's drawing, but the color is always green. So to draw this terrible green. Also, something here is happening. I think the angle for the cosine needs to be in regions, which is weird because the people gives us like from 0 to 1, but I need to put 0 to 2 pi the radius. Okay, so terrible circle, but we are getting there. Maybe we can change this to a higher frequency. 5. So it's a bit better. Maybe we can fiddle with it later, but right now we have a problem, which is the color doesn't show the actual content of the scan. So let's multiply it by the contents, see if it works. It doesn't. So it's cool, but not exactly useful, and I don't know why there is a big rectangle. I guess it's because the pivot angle didn't change in this first tick, because it starts at random values or 0. I don't know how it initializes these variables, which number is in here in the first time it runs. But let's pick that maybe if it brings the pivot angle at the start, we can get some idea. Yeah, it's we can change this later. I think for now the color is more important. So just multiplying the color by a constant doesn't gives us much. What we can do is make the things here, make a var raw color. Sorry, this is already taken, so I color. It's maybe a color. If PP using green, let's put it 0 and 55 times the contents. So yeah, so now we have that the higher the contents, it's between 0 and 1. The closer this value is to 255, which is the maximum value for the green channel. And the lower the contents, the closer this comes to 0. So let's change this. Now we have a somewhat working scan, finally, after hours of coding. But it isn't very good. We could increase the number of samples. Maybe 40 is fine. Now in the radius direction it is okay, but we can see that in the borders, and it's to be spaced out. The spacing can also be increased by increasing this frequency. Now this is fine, but again the border is all wrong. So let's actually get the current draw radius. Be applying the draw radius minus a delta, let's say 2 pixels. So now it's inside this green radius. I don't know exactly what causes this this like overshoot. Maybe we can, instead of doing this, around this number for x1, x2, y1, y2 to the closest to the center. So the closest number to the center will be just this rounded down. So let's see. I think there is a floor function. I'll check the documentation. Yes, there is. So maybe just by using the floor function here, which I can probably fix this. Yeah, control. Okay. It's not working. Why is it not working? Yeah, the floor function actually should be the current draw radius here. So now it's the lowest radius when it's between 2 pixels, but it still doesn't work. Let's make maybe with -1. So removing 1 pixel. Actually, -1 should be here. It's a mystery. This kind of works. I don't know what's causing this here. Probably, well, the angle is the sine or cosine are 0 and 1 here. So maybe something about that. Oh, right. I was thinking about it while I was coding, but I didn't do it. So actually, the current draw radius isn't the same for the 2 points, right? Because we actually don't have one radius, we have a delta radius. Because in this sampling, sure, we are sampling this as exact radius, but the last time we drew it, it was less. So we have to actually fill the gap between the two radius. So, how do we do this? We can change the draw radius by half the delta radius, right? So let's put just this R, let's call it, and x1, let's do it minus y1 minus x2 plus y2 plus. So what's this delta radius? It's just this draw radius, the difference between two draw radius, right? Yeah, actually, instead of doing half of this delta upwards and half downwards, or I should say half outwards, half inwards, I'll just do one inwards, so we don't have that overshooting problem again. So 1 times that. So no, arm will be the, let's call it radius minus, and that same equation for the draw radius, but basically we need to do this if I plus 1 less, so like this, right? And now we don't have that that problem as much as we were having before. Now I think it's just a number of samples problem. Let's put it like this. Yep, I think that's a good value. And also the frequency, let's put it. Yeah, I think that's pretty great actually. Can also change this value probably. I still have to correct this rectangle in the beginning. Yeah, maybe keep it at 3. It's fine tuning. Maybe 2.5. If this will work. Yeah, it looks fine for me. And this initial rectangle, let's do it like this. If we put the angle, let's put this angle greater than, let's say, 6 degrees. I would say it's maybe 10 degrees. So 1 over 36, because 1 degree would be 1 over 360. So 1 over 36 is the same as 360. If it's this big of an angle, just return. So now, when the angle changes too much, we don't see it. So this is pretty cool. It's working great. The only thing we have to see, yeah, just as I thought, the pivot is completely wrong first on our screen. And if we reboot, we can see, yeah, it was like looking to the left, and the screen thought it was looking downwards. And it also is rotating the wrong direction. This can be easily changed by just using, I guess, minus the angle. So now at least it's in the same direction, but you can see it's basically half rotated. So we can undo this, sorry, not half, but 90 degrees rotated, and we can undo this rotation by doing minus 1.25, which is, sorry, plus apparently 0.10, which is a 90 degrees angle. Let's see, it looks like it's matching. The rectangle apparently came back. Let's see if it's consistent. Yes, it is. Why is it? Let's do something different. Let's start the previous angle as 2. Yeah, because I thought to move this. So this is a very terrible, like, of course the angle won't be ever 2 because it's between 0 and 1. So we can check if it was 2, then we don't continue we don't draw it. So basically, if this angle greater than 2, or actually we can do it with the pivot angle instead, and that's angle. And with this, so the pivot previous angle will be 2 because it starts as true, the pivot angle, and the pivot angle will be just correct. So if the pivot previous angle is greater than 1, which is 2 is greater than 1, it just returns, doesn't draw. And it looks like it's working. Now if we change the radius, it cleans the screen and change the radius it's looking at. So if we put a very small radius, we can see the individual veins quite nicely. Very high resolution for each vein. So I know this approach isn't great. You can see some black dots. This isn't like, there is no order. It's just the way we draw the triangles. Sometimes there are some space left between them, but this works nicely, and like you can see where the art is at. So pretty cool. Now let's see, for example, how far we need to go to get gold. I'm guessing like something appears at 50 kilometers. So yeah, so about 50 kilometers. Actually, there's something here. But I think that's in the sea. Let's turn this towards the mountains. Yeah, apparently in the sea we have gold, but forward we don't. So maybe venturing the sea next time. That's what it looks like. So I guess this is enough for now. It's already late in the game and it's in real life too. So I guess see you next time.